Hello and welcome back to the 8-Bit Guy. So, believe it or not, it has been 3 years since the last update on the Commander X16 project. In fact, I still have the original prototype that I showed off in that last video, and it does still work, by the way, but a lot of you guys might have thought the project was dead, or just had forgotten about the project, or many of my newer viewers may not even be familiar with the project in the first place. So what I have here is the final prototype. This is basically the production board. It has been finished, and I am ready to show it off. We actually had the latest version out on display at VCF a few weeks ago for people to come by and play with. But for those that may not be familiar with the system, let me give you an introduction to it. So before I explain what the system is, I want to start by explaining what the system isn't. It's not a clone of the Commodore 64 or any other machine. It's not backwards compatible with the Commodore 64. It will not play any games or run any software designed for the Commodore 64. So now I'll try to better explain what the intent of the system is. Looking back at the product timeline for Commodore, they produced a number of 8-bit systems starting with the PET all the way through the C128. And all of these systems were incompatible with each other, well, except for the C128. But at the same time, there are certain aspects of these machines that are the same, that are compatible. For example, if you write a simple text-based program in BASIC on a VIC-20, and then save it to disk, you can read that disk and execute that same program on a C64 or a Plus4 or whatever. There are certain things like that that make a Commodore system, well, a Commodore. Like the kernel and basic ROM and a number of other things. So what I wanted to do is create a system from off-the-shelf parts, a system that we would never have to worry about finding old, out-of-production parts to build one. And I wanted that system to be sort of like a spiritual successor to the 8-bit line. Unlike the Amiga, that was really a totally different computer with virtually nothing in common with its predecessors, imagine if Commodore had made another computer in 1987 as a follow-up to the 8-bit line. Well, that's what this product aims to be. So just a general overview of the system, we have a 6502 processor running at 8 MHz. I think that's at least twice as fast as any 6502 based system of the 80s, as far as I know. It comes with 512K of RAM standard, but is easily upgradable to 2 MB. We have a really powerful video chip known as the Vera, which handles all of the text, graphics, and even some of the sound. We also have a Yamaha YM2151 chip for even more sound and music. But most importantly, we have the Commodore kernel and that familiar BASIC 2.0 as the heart of the system. In fact, this is the only thing that remains compatible with all Commodore systems. For example, I can write a small BASIC program on my C64 or VIC-20 and then save that program to disk. Then connect the disk drive to my Commander X16 and I can actually load in that same BASIC program and it will run. Okay, so let's talk about BASIC in the Commander X16. It's the same BASIC as you'd expect on the Commodore 64. You know, you can do things like this. We've added a few commands to it, so I'm going to show you some of those commands. One of the commands is the screen command. So you can do screen 1, for example. That will give us 80 column display. And I like coding in this particular environment. 80 by 30 is a pretty comfortable screen size. You get lots of screen space. Of course, the default boot screen that I showed you a minute ago, this is 80 by 60, which, this is okay too if you have a sharp enough monitor for it. There's also some other weird screen sizes. So you can do, and by the way, I'm doing a shortcut here. So just like in most Commodore Basics, you can type the first letter and then, like for list, instead of typing list, you can type L then Shift I. So, all that kind of normal stuff that Commodore users are accustomed to are here. But for our screen command, you can do S Shift C. And then we have some interesting screen sizes. Like this one is 40 by 60 columns, which is a weird shape. Then this is also like a really big one, and then screen 6. This is almost like a VIC-20 size screen. This is 20 by 15 columns. It's really huge. Probably don't have a huge amount of use for that. But oh yeah, you can also hit the F4 key to alternate between the two most common modes. So this is your default mode, and this is your 40 column mode, and you can just do that. So anyway, enough about screen sizes. Let's talk about some of the other added commands. So we do have a command called DOS, and by default that just shows you the disk drive status. But you can also do stuff like put a $sign in there, and this will give you the directory. Because I'm running an emulator right now, there's all kinds of garbage in here you probably wouldn't see on the real machine in the directory, so just ignore all that. But anyway, you get the idea. You can also do CD commands like DOS, CD, and then go into a subfolder, whatever that would be. But I don't have any on here right now. But yeah, that's also a supported feature because, these SD cards that we're using are going to hold a lot of data. So you're going to want to organize your files into different subdirectories, just like on a DOS machine or something like that. So another one of the commands I want to show you is the mouse command. You can just type mouse 1 and looky there. The mouse is, it just turns on. It's automatically supported by the kernel. Mouse 0 will turn it off. So to better demonstrate the mouse, I wrote this little program called LightBright. It's a really simple little basic program here. I'll actually show it to you. I mean, it's literally that small. And it's just to show you how to use the mouse in BASIC. This is a number of small basic example programs I hope to ship with the computer just for people to get an idea of how to use it. So with this program, you can just select a color and then literally just draw around with it. Here's some example pictures I drew. Now, unfortunately, the program doesn't support loading or saving your work, but that's something that you could always add to the code if you wanted it. Okay, so another thing I want to show you is the color command. This works very similar to like on the Commodore 128, but it does allow you to specify foreground and background colors. So I can say, for example, I want color 3,7. Maybe that's not such a good combination. Let's do 2,7. There we go, red on yellow. And so, yeah, you clear the screen and now everything's that color. So, yeah, you can do color 1,0, get black on white. There you go. So that's a nice handy feature to have. We also have commands like locate, which is also from the C128 and +4, where you can tell it to go to a specific place on the screen and then do something. So that's very handy when you're writing basic programs and you want to move stuff around on the screen. We also have a joystick commands, also very similar to how it works on the 128. So you can just do print like joy 0. There you go, and it will return 16. We also have the ability to use hex numbers, so you can put this like in a poke command or a print command or just any kind of math problem. I can say like print B2CF or whatever, and it will automatically convert that to decimal. Like I said, you can use that in poke commands, which is handy sometimes, wherever you need. And then, of course, we have the vpoke command. In fact, I'm going to show you a perfect example of that. So let's say you want to poke directly to video memory, which is separate from the regular computer memory. So it's very handy to be able to do this in BASIC. There's actually 2 banks of video memory. I'm going to do bank 1, B1000, which is basically going to be the first character at the top left of the screen. And then I'll just put like a 1 in there, which I think will be an A. And yeah, there you go. So there's your B. So yeah, BASIC is very, very similar and in most cases compatible with Commodore 64 BASIC and VIC-20 BASIC, but we have added just a few features to make life a little easier. Now here's another example written in BASIC. It's just some bouncing balls, and I often use this program as a benchmark. So for comparison, here's how the same program runs on the Commodore 64. Same number of balls being animated. As you can see, the 8 MHz really makes a big difference in performance. And here's another little program I wrote in BASIC. It's just a slideshow that shows random pet ski art. It actually decompresses this in real time. Again, a testament to the faster processor. And since the screen has slightly more rows than a C64, that leaves a little blank space at the bottom, so I used that to show the information about each piece of art. So we also have graphics commands, so we can go into graphics mode like this, and then let's say you wanted to draw a line. We could do 10, 10, 100, 100, and then give it a color, say, I don't know, black. And there you go, you get a line. So to take that one step further, I wrote this little program in BASIC that will draw random lines on the screen. So there you go. Yeah, we've got a lot of graphics commands. I'm not going to show them all here, but there's a bunch of them. So you can do a lot of really powerful stuff in BASIC. And just a refresher on RAM layout. Basic is allowed to use this area here that we're calling low memory, which gives it a similar amount of free basic RAM as the Commodore 64. Now this 8K area here is where all of the extended memory lives. Now this area is banked, and depending on how much RAM you have installed, there can be up to 256 banks here, totaling 2 megabytes. And we're calling this area high memory. The ROM area is also bankable, which allows us to have a lot of extra stuff in ROM as well. Okay, let's talk about video features. It has 3 types of analog outputs, starting with your standard color composite, and then S-Video for those in North America, and then what most people probably use, standard VGA. However, the VGA port can output 15 kilohertz or 31 kilohertz, so that means you can use a regular VGA monitor, or if you want to build an appropriate cable, you can use monitors like the Commodore 1084, or arcade monitors, or RGB modded televisions. But these are all analog formats. If you want HDMI, you'll have to use an adapter. I wanted to show it running on composite and S-Video, so I've hooked up my Samsung TV and then an early 2000s LCD television with S-Video for some comparison. Now, unfortunately, at the moment, when you power it on, it always defaults to VGA, so I have to blind type a command here to switch it into composite mode. Another unfortunate issue is the default resolution has it overscanning off the edge of my TV screen. This isn't an issue on VGA displays, of course. However, I made this little program which will let you adjust the screen size and position and save the settings to disk. Now, eventually, I hope to get something like this integrated into the kernel so it will save your settings to NVRAM and thus remember your configuration each time you power on, but that isn't working just yet. Composite looks pretty good actually, but S-Video looks even better, which is to be expected. You might be surprised to see that even in 80 column mode, the text is very readable on my composite display. And now, I'll briefly show you a couple of games running on composite. Now, this game needs no introduction. I'll talk more about it later in the episode, but as you can see, it looks beautiful on my television, exactly how the original game was intended to be viewed in the first place. And here's Pesky Robots running in composite mode. And so my point here is that you basically get a choice of 4 different display types, and the X16 will be happy to run on any of them. We even have a feature to disable the color signal on composite. This will give you a really clean image on a monochrome CRT, should you choose to go that route. Now, let's talk about the actual video chip and what it can do. It does have a standard character mode, which can operate in 16 or 256 colors. That also includes 40 or 80 columns. You can also do bitmap graphics at several different resolutions like 320 by 240 or 640 by 480, and you can choose multiple different color depths all the way up to 256 colors. And the Vera supports 3 different layers of video. You can define the top or bottom layer to be either characters or bitmap graphics, and the third layer is sprites. This gives enormous flexibility for the programmer and provides a lot of 2D hardware acceleration, which means much less work for the 6502 processor to handle when working with 2-dimensional graphics. Moving on, let's talk about sound. There are 3 methods to create sound on the X16. The first option is the Yamaha YM2151. Now, this chip was used in all kinds of stuff from the 80s and 90s, including the Sharp X68000, tons of different arcade machines, and a number of professional synthesizer products. The Yamaha chip gives us 8 stereo FM channels, and it means there's a lot of ready-made tools to compose music for it, and a lot of music tracks out there we can already play. Next, we have the Vera PSG. So, yep, the same chip that gives us video also has its own audio. It has 16 stereo channels and can produce the same waveforms as the SID chip on the Commodore 64. And also, part of the Vera is a DAC for playing back digital samples, which can be as high as 48 kilohertz. Now, to demonstrate this, I'll show you Calliope, a dedicated music player for the X16. It can navigate subfolders, and we have quite a few songs already imported into it for testing. I'll let you hear a song using the Vera's PSG. As you can see by the blinking dots at the top right, this is using 4 channels of the PSG. It sounds a lot like the SID chip on the Commodore 64. Of course, unlike the SID chip, we have 16 channels. At the moment, the most voices used are by this piece called Green Motor, and it uses 13 channels. You would need 5 SID chips to do this on a C64. This song, called Colony, uses only the Yamaha FM channels, and it uses all 8 of them. And you can probably tell FM synthesis sounds a bit different from a PSG. Some songs actually use both chips, such as Petsky Robots. As you can see in this demo, we're using 6 of the FM channels and 3 PSG channels. And the reason for this is that the music has been ported over from the Sega Genesis version of the game. The Genesis has a 6-voice FM chip and a 3-voice PSG. Let's have a look at the board itself. It's a standard micro ATX form factor, so you could put it in just about any case you wanted to. This case is a mock-up design originally done by Parafractic. It won't ship with this case, but I just wanted to show it to you as an example. Personally, I think this case is a bit too large since there's a bunch of dead space in the front due to the power supply. So let's take a little closer look at the actual board. So talking about power supplies, by the way, so it is a standard ATX power input, but you really don't need very much to run that. In fact, I actually run mine off of one of these. It's just a little, I think this is an ATX Nano or something like that. Yeah, so it just runs off a little wall wart. So just an overview of some of the things you'll find on the board. So this is your main ROM. These are all RAM. This is your Yamaha sound chip. This is some other decoding logic and whatnot. And then, of course, you got your CPU here, regular 6502. And your 2 versatile interface adapters. And then, of course, this entire board up here is a dedicated Vera board, and it actually contains your 3 different video output ports and your SD card slot. And back here we have 2 Super Nintendo ports, and we went with that simply because we do not like being limited to a single button on Commodore joysticks, and so this is quite a bit more versatile. And even though there's 2 ports on the board, technically speaking, the board has 4 Super Nintendo ports. You can access the rest of them up here through these pin headers. If you needed to have like a 4-player game or something like that. Maybe if somebody wants to design Mule for the Commander X16. Anyway, moving along, got your audio port here, your standard Commodore disk drive port here, and then standard PS2 keyboard and mouse. And so that's the overview of the main board. There are, of course, 4 expansion slots, which there's not a lot for those right now, but one change that there will be towards the end of this is right now we actually have what we call a user port. Actually, it's more similar to a PC parallel port, and it does use one of these VIA chips. However, we've decided to deprecate that. We're actually taking one of these chips off the board because we really just don't need it. That way it'll actually reduce the cost of not just the chip, but the socket, the pins, and a lot of the other circuitry involved for ESD protection and all that kind of stuff. And so what we're going to do is we're going to move that to an expansion card. So if people do need the user port, then that will be available. It'll just have to go on the expansion bus. So we also notice we do have a battery down here, and we have a real-time clock, and that actually does work. It stores the time and date, and you can read that with the regular TI $ command, just like you would do on a regular Commodore. Now, even though this can be mounted in an ATX case, I actually just put little rubber bumpers on the bottom of mine. So the board sits nicely on a desk. You'll notice we have some jumper wires and stuff down here. These, of course, will be going away in the next revision of the board. But, you know, it is what it is. It's prototype. But let me show you something else. So this is another Commander X16. And this is actually made by Wavical. And it basically boils down to the fact that he got tired of waiting for us to produce one, and it is mostly an open source project, so he just produced his own. And so it's basically compatible. It's the same basic idea as a Commander X16, but he's obviously redesigned this to be considerably more compact. He's done that by creating a daughter board here and another daughter board for the audio components. And you can see it is considerably smaller than our board. So, yeah, that's kind of cool. And I actually showed this at VCF inside of a custom little case, which is pretty neat. Of course, you won't actually be able to buy one of these, at least not anytime soon. But, you know, if you want to build your own, well, there's always that option as well. Okay, so now I want to show you some of the games that have been developed for the system, starting with this one, Chase Vault. Now, this is one of the first fully playable games to be finished for the X16, which was designed all the way back in 2020. The game mechanics are similar to Pac-Man, of course, even if the graphics don't actually resemble it. Next, I'll show you Take to the Skies. This is a playable work in progress. It aims to be an RPG or adventure game of some kind. We'll see how it goes as the game continues to be developed. Here's a game many Commodore and Atari fans may recognize. It's called Rally Speedway. I had this game on my C64 back in the day, but much like today, I am terrible at it, so I can't really demonstrate it very well. Next up, this is Bricks. It's a pretty well-polished Arkanoid style game. It can be played with a mouse or joystick, but I think the mouse is probably the best way to go. And here's Invaders. I have to show this on the real hardware because it requires a joystick. This is a very modernized version of Space Invaders, and you can start off defending the Earth from the aliens, and once you complete that, then you have to move on to Mars, and so forth. It's pretty cool. And now, Super Mario Brothers. So a lot of people keep thinking this is some sort of emulation, but it's not. This is a direct port of the original game over to the X16, so this game runs natively on the X16. Unfortunately, we won't be able to distribute this game with the computer for obvious reasons, but I'm sure people will be able to find it in the dark areas of the internet. Now, I've shown this off a few times, and don't get too excited. This is just a demo. It's not playable in any way, it's just to show off the X16's video features. But if there was any doubt as to whether a port of Sonic could be made, well, I think we know the answer. This is a raycasting demo. You can control it and walk around, but there isn't much else you can do. It runs at about 10 FPS, which isn't bad considering the hardware. Needless to say, you'd never be able to pull this off on a stock Commodore 64. Speaking of raycasting, this demo here looks rather impressive, but it's not really doing any real-time calculations. It's just loading individual frames from the SD card. Still fun to watch though. Okay, let's try out another game. Here we have Flappy Bird. And while I'd love to demonstrate this further, I really suck at this game, and that is about as far as I can get. But this is a really well done port. And of course, don't forget Attack of the Petsky Robots. I've actually been working really hard on this code the last month or two to try to get it completely functional and get all of the bugs out of it, make it really stable. I still haven't updated the playfield graphics to the Amiga graphics, which is on the to-do list, but the game is completely playable the way it is right now. The last thing I'll show you is Petaxian. It's a Petsky-only game originally designed for the C64, but has been ported to the X16 as well. Now, this is just a sampling. I mean, there are like 100 titles already created that are available for download on the Commander X16 website. But we still have plans to start with this Micro ATX board, and then eventually move on to a Gen 2 board, which uses all surface mount parts to help reduce both size and cost of the board. And then eventually to have a Gen 3 board that could be an FPGA or ASIC and, be about the size of a Raspberry Pi. But in order to make it to stage 2 or 3, we have to first get stage 1 out the door and have it be a success. Now, we do plan to sell every board with a custom Commander X16 keyboard like this one. This is made by Perix just for the X16. As you can see, it has all of the Pesky characters and other Commodore functions on the board. It's basically the same keyboard as this black one you can buy on Amazon for around $20, but we've had the color and symbols altered for our purposes. And if you don't care for the little keyboard it comes with, then there's always the option for the high-end WASD keyboard if you want to spend a little extra money. However, there will be no case with the first gen board, but there might be a custom case with the second gen if we ever get that far. Okay, so let's talk about something else. So a lot of people refer to this as, the 8-Bit Guy's project or the 8-Bit Guy's computer, but this project is so much bigger than just me. And admittedly, it was my idea, and I have been around since the beginning, but it has grown to include dozens of people. I mean, there is no way I could have done all of this by myself. In fact, most of the credit actually goes to like 3 different people, which is basically Michael Stile for doing the kernel and the emulator, and then Frank Vandehoof for doing the Vera chip, and of course Kevin Williams for doing the motherboard design. And then there's like dozens of software developers out there who have been writing games and updates and finding bugs and helping us improve the system. In fact, we've spent countless hours working on this system, and a lot of us have also spent a lot of our own personal money. Myself, I've probably spent somewhere around $12,000 of my own money just in both, parts costs, manufacturing costs, administrative costs, whatnot in doing this project. And some of the other people have also invested thousands of their own money as well. Now, ultimately, we'll probably need to do some kind of Kickstarter or other kind of crowdfunding in order to pay for the hundreds or thousands of these machines that we want to get built. But we're not quite ready to do that just yet. What we'd like to do starting right now is attempt to produce 50 units just like this one. And we intend to give a few of these away to some of the dedicated developers who have been heavily involved in writing software. And then we'd probably sell some more at a discounted price to those who are close to the project and want to start developing. And then sell the remaining ones at full price to whoever might want one, with the understanding it's still a prototype. So doing this will not only help us find any remaining bugs, but that means there will also be more software available at time of launch, which is always a good thing. But I think the main thing actually is producing 50 of them will give us an idea of what it actually costs to produce these in bulk. But we really need to reach out to the community and ask for a little bit of financial help. So don't think of this as donating to the 8-Bit Guy. I already have that. That's through Patreon. Any money we raise through this will go directly to the X16 project to help get these into production faster. So there's going to be a link down in the description field for a GoFundMe, as well as a couple of alternative methods to donate. But what else can you do to help the project? Well, if you're a programmer, you could download the emulator and start writing some code. If you also want to be more involved, there's forums on the X16 official website. And of course, there's the official Facebook group. And we also have a Discord group for programmers. So I'll put links to all those down in the description field as well. Now, there was a ton of other stuff I really wanted to show off about this system. For example, running GEOS in full color. We can do that. I wanted to show off our built-in assembler. I wanted to show off some more basic commands and just talk more about some of the future design aspirations that we have and where this product might go in the future. But the video's getting pretty long already, so that's going to have to wait for another time. So that's it for this episode. As always, thanks for watching.